Okay, so you get everything working at 24 volts. And 12-volt batteries and 12-volt solar panels, and the windmill. So the windmill and the solar panel is getting 19 volts power supply added. The batteries are getting 11.5 volts power supply. So see over here we have up to 150 watts going into the and it's quite cool. And so is this. It's warm. The wind is not really great. Only have 3 volts coming out of the middle. Oh, there's no wind at all right now. So basically what I did is this here. So input from solar panels and the generator is getting 19.8 volts added to its input, and that's going over here, so you can see 23 volts output, and then the batteries are getting 11.5 volts added. And charge controller doesn't really like it because it doesn't see the battery, but I think it's still charging. So it's same as this, except I'm adding power supply 12 volt battery. I'm adding 19 volts to the input from solar and the wind generator. Wind generator is not kicked in yet to see the effects. I don't think we're gonna have the wind today to do that, but we'll check it out later. Okay, till we get some wind, I'll see you. So this bulb here is basically I'm driving the generator. The generator with 12 volts through to a bulb, so that it's putting out about 3 volts onto it. Well, right now it's 4 because the windmill started turning, so 5, 6. So when the windmill is producing, which is starting now, it's turning a little bit. Let's show you that. Not much at all. So basically I'm adding 12 to the 20 volts to the battery so that I can have it hooked up as high voltage, or let's measure. Put this to ground. Hold on a sec. Okay, so input to the MPPT controller we have 20 volts, which is kind of low, I would say, because that's basically just from there. And the battery connection we have 20 volts, shows right there, and output we have 20 volts, which is going to the house. Okay, I'm going to check that too. So that 20 volts from shed going into the house. There's not a controller and 12 volt batteries, so I'm gonna go inside and okay, we have a little bit of wind, so she's spinning. That was not picking up because it's behind the roof. Let's see what it does here. Okay. So we're getting 9 volts on the generator, 22 here. Okay, losing the wind, it's cutting out. Still pushing, but not as much. 29 watts to 93. That's from today. 17 volts. Okay, I'm getting another gust of wind. Didn't last too long. So this is going out to the inverter and the solar controller. This meter here. Okay, so I'm gonna take some amp readings here. Set this DC. Okay, so this is the grid tie, 3.4 amps. This is going to the batteries, 2.9 amps. Then to the controller, and this is going to one battery, and this is the other battery. Okay. So then AC. Come on, reset. AC we did about 0.8 amps at 120 volts. So it's about 100 watts. And there we have 6 volts. Just trying to get to normal, but not quite there. Focus. Yeah, the wind is kicking in and out. It's only about 14 kilometers an hour, so it's not very much. Let's have a look. She'll spin a little slower because I have the boost voltage on there, but she's ready for more wind, that's for sure. This is very nice actually. It's producing a few amps. About 8 volts. It's not even pushing 12 yet because of the RPMs. But as long as she's producing, that's the main thing. Looks pretty nice actually, pretty steady. I can hear the relays clicking inside there, so it's you can see it right there. So this is the 19.8 volts right here. So solar panels, and they're both on a 12 volt system as before, but I'm adding basically 20 volts to the input. So that, then is going to the watt meter. Okay, so solar panels, watt meter, through watt meter to grid tech and inverter and MPPT charge controller. Going to batteries, 12 batteries, but I'm adding 11.5 volts in between, adding a power supply so that I can have the system on 12 volts, well, up to 50 volts, 18 to 50 volts, and reduce losses. Now it's going pretty good at 9.5 volts. Actually, let's measure the amperage getting from the, oh, we just lost the wind. From the it's gonna be hard to get in between there to measure just oh, right here. And coming from the windmill, which is not much right now because it's barely turning, but this is where we can measure the amps coming from the windmill. So right now, yeah, the wind is pretty much dead because we only have 3 volts, so it's barely spinning. But as we can see, I have to reset this now again. The amp meter. So we're on an amp meter right now. So right now it's almost nothing because it's barely spinning. But she's working pretty good. So what I'm gaining with this setup is I'm reducing power losses because of the voltage, and I'm enabling the grid tie inverter to work, because this works from 18 to 50 volts. Okay, so right now it's producing, as we saw, it's using about 3.4 amps in and about 0.8 at about 20 volts DC, and it's putting out about 0.8 amps at 120 volts AC, and that's connected to the power going into the house. So all in all, I think that's a pretty good system. So I have power going to the inverter and going into the house power, and I have I'm charging the batteries here, 2 batteries at 12 volts and 2 batteries in a house in a basement. So it's all encompassing system pretty much, and I have solar and wind with a controller, wind controller with boost and kickstart, and I have MPPT and PWM charge controller for the batteries, and also from the output from the load I'm sending it to the house through another MPPT controller and charging the 2 batteries inside the house at 12 volts and using it in the house. So that's a very good system, and it's all do it yourself. I just purchased the controller and the grid tie inverter and the controller is designed and made by me, and the wiring, so it's messy, but it's a project, it's a work in progress. So right now we're producing some power. Okay, so as you can see, so 87 watt hours and 3.6 amp hours so far. And yes, I'll have to measure, get a plug and measure how much power I'm using from here, but that's besides the point. I know I'm adding power. I'm adding power supplies, which is basically doubling the voltage, so that I can work on a 24 volt, 22 to 50 volt system, and also have grid tie. So then that basically goes right to the house. You see the two lines, and it's going to the meter. Meter is being slowed down. I'm only producing about 100 watts of AC power, but that's better than nothing. So that's it for now. I think the wind is spinning right now. I don't know, but it's starting to pick up. Watch the start. Decides what direction it's going from there. So it's just little gusts of wind. That's all we got. 14 kilometers an hour. Yeah, it's turbulent. It's coming from north. There's trees there in a way. Leaves are standing full up, so that's gonna help. And there's the solar panels. They're kicking out as much as they can.
Fly so high, I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through. Flying, get on board. We're smiling on top of the world. Dangerous times, don't fly too high. Be sure to keep the ground in sight. Fly forever if you keep it tight. Love the world, but keep the sky on your mind. Flying, get on board. We're smiling on top of the world. Flying,
basically what I've done is
just trying to
show
make
you.
it normal. But not quite there.
Okay. So what we have is 12 volts SMPS. Power supply.
So only about
So it's 12 volts
14
and 12 volts battery. So there's two, but doesn't matter since they're in parallel. Okay, that's in shed. And then this goes in the house, and that's the same two batteries in parallel, 12 volts, and we get the 24 volts out from here and goes into the SMPS controller. And over here so this is plus, minus, so I'm adding 19.8 volts SMPS. 19.8 volts SMPS. Okay.
Just on the edge.
And yeah, these are in series. So
Nothing else is speaking.
that one is done too.
So everything's working pretty good. So everything's working on 12 volts like it was. So again, what I'm adding is from the controller
Okay, this is a little messy, sorry about that.
going to batteries. I'm adding from this power
So
supply.
that's disconnected there.
Rectifier and
So
capacitor
it's in parallel.
11.5 volts. So that
Okay, and then over here there's a switch.
20 on. And I'm getting in.
Just to be able to disconnect and reset the wattmeter. The wattmeter doesn't have a reset. It's to reset the watt hours and amp hours. And it only goes to 65 amp hours and something like 1,000 or 1,600 watts or something, watt hours. So
Coming in.
I'm not sure how this is hooked up right now. But anyway, this is connected here. Alright, so let's show it over here. Okay, so here it is, adding the 19.8 volts, 6.3 amps, or 6.5 in series before the watt meter, and then it goes to grid tie inverter as 24 volts or more, and MPPT charge controller, and adding 12 volts here to the battery at 2.5 amps.
Then he's going to watt meter.
I'll redraw that and I'll show you.
Okay, so salt panels, watt meter, 2 watt meter to grid.
Okay, so I'm gonna go out
Charge controller. Going to batteries, 12 batteries.
and
But
show you
adding
the
1.5 volts in between. Adding the power supply. So that I can have the system on 12 volts. Well, up to 50 volts. 18 to 50 volts. in its losses. Now it's pretty good at 9.5 volts.
Yeah, so I'll go out there again once it's spinning to show the numbers. Okay, later. Okay, well, as you can see, there is some wind, but not enough to spin it up. So I'll just show you inside, just from the solar panels, basically, the voltages and so on, since I added a 12 volt supply. Okay, so the voltage in from the solar is 22. Okay, and I have the 12 volt SMPS power supply in series with the solar panels. This fuse is pretty hot. Let's see how much I'm going through there. Two amps. No, that's almost 5 amps there. 150, 120 watts. Okay. Let's see what we're doing out here. It's dying off the wind. Anyway, so yeah, we have 24 volts right now, and 22 volts coming into the controller. The inverter is running. So I have the 20 volt in series with the solar and the wind, and then I have the 12 volt SMPS power supplies in series with the batteries. Okay, so that's the difference. So right now there is no wind, so I can't really show you anything else. There's a little bit, you can tell by the flashing LEDs. That's every rotation of the anemometer. I'll get a pulse. Okay, so let's just get some readings over here again. Yeah, about 100 watts. Average. 110. 320 watt hours. 5 amps. That's really good. 5 amps. Oh, 8 amps. I'm just checking temperature. This one is pretty warm. Wow. I should get the thermometer and check him. And this guy, oh, that's pretty warm too. The fan is not running yet. Okay, so I'm going to take some readings of the temperatures. So first of all, I'm going to see the temperature of that fuse. 33. Wow. Okay, then this power supply 2928. This one is 57, 58. Wow, I'm gonna have to check the amps. This is 38. And what else we have here? This series 35. Basically the air temperature. Okay, it's just kicking in. So on the solar in, we have 2.4 and the grid tie inverter 4. Battery 2 amps. We're into the complete controller. This is one battery, 2.7. This is the other battery. 0.4. Battery's charging. And going out. So the house, not much. Okay, this battery's gonna run out, so the video is gonna stop in time. Okay, so this is too hot. The amps going through that. Let's see. Let's basically this one. Going to MPPT controller. 8 amps. No, it's, sorry, I'm on the wrong scale here. I think I already checked that. So reset 2.6, so it's drawing its maximum 2.5 amps. That's why it's getting hot. Okay. Will kicking some watts. Okay, and one more. So I'm gonna put it on AC reset. And let's see, let's 1 amp. Wow. 1 amp at 120. So that's 120 watts going out. Okay, so I need to make sure is that this fan is going to start coming on. to cool this off because I don't want it to be hot. So this transistor is not working right. So right now I'm just gonna turn it on by jumpering. Plus. And my plus. I can't actually do that here. Minus. Huh. Oh, actually, I see there's a problem with my minus. So I need to connect that to the minus of the system. Okay, hold on. Okay, so I got the fan running to cool that guy off. I just turn it on by jumping it, so okay, 36. It's not bad. And this guy here, 55. That's a little concern to me. So here's 37, that's not bad. And this fuse, 45. Okay. I have to check out what size that is. Okay, so we get the temperatures under control. This is 36, just pretty much ambient. I took this fuse out because it's already fused over here. And then over here we got 32, and this is down to 42 already because I get the fan going. Okay, that's it. Now I'm gonna upload this for you guys. So another shot over here. Look at the 80 watts. Okay. And DC. Reset. Okay, so 5. This is from solar. 2.3. Okay. The batteries 4.3. And the one battery is 0.2, and the other battery is 4.6. Wow. Okay, it's a lot. And 4.5. That's basically going to the power supply. Okay. This only has 2.5 amp power supply. That's running a lot. AC. Oops. AC. Reset. About an amp. So it's still drawing about 120 amps, watts. We're putting into the line. Okay, so you see, reset. .8 coming in. And 4 coming out. Okay. From in-mail 8.2. And let's see what the in-mail is leaking out. Much right now, 0.1. But it's already, wind speed has reduced. It's still producing something. Okay, that's it for now. So that's electronically boosting the voltage. What I want to do next is I'm going to add another 3 blades on a propeller. Okay, I don't have no drawings. So one is going to be freewheeling. It's just to create more vacuum behind and basically increase the wind speed going through the first blades. So that's going to be next. I gotta get some blades, and that's going to be some work, mechanical work, physical work. So okay, I'll keep you updated. Cheers.